is going to cover graphing systems of inequalities. And what's really important with systems of inequalities is that we want to make sure that we are graphing two different things that we have already graphed so far this year. The first one is a system, which means more than one. So far, we've been graphing a bunch of systems of equations, which means more than one line, and we want to know where those lines intersect. And then inequalities are where we graph what looks like a line, but then we have to do some shading either above or below that line, and we need to make sure we figure out if that line is solid or dashed. If you do not know either of these two concepts or simply need a quick review, make sure to talk to Mr. Schmidt because he has old videos and assignments for you that you can work on to review those concepts if you need to. Before we get into systems of inequalities, we're going to go through graphing a single linear inequality on a graph. When we are dealing with inequalities, we want to work with the form y equals mx plus b, like we've done probably a million times. Hopefully that song popped into your head at least a little bit. And we want to know the slope and the y-intercept for each inequality or equation. For this one, our b value is 4, or the ordered pair 0, 4, which would be right here. Our slope is 3, or the fraction 3 over 1, which means we are going to go up 3 and over 1. One of the reasons why I'm going through this rather quickly is that we've done this a lot. And I think that if I spent a lot of time on each video going through concepts that we've covered a bunch before, I think, they would get pretty long. So if you need more help on graphing these types of lines, make sure you talk to me. Now, one of the important parts is to figure out if the line is dashed or solid, which means can we be on the line and still a solution? Since this is simply greater than, that means we need a dashed line. And that's usually how I graph the dashed line. Now, the important part is shading. So for this problem, we need to go greater than. So I pick a single point. I'm going to pick right here. And I go above or greater than that point. And that means our shading is over here. And I'm going to shade kind of lightly because I'm going to show you what happens with the next line, which is right over here. We have 2x minus 2y is less than or equal to 6. In order to graph this using the slope-intercept shortcut, we need to get y by itself. So we get negative 2y is less than or equal to negative 2x plus 6. And once again, if you haven't seen this or don't remember this, make sure you come talk to me. From here, we need to divide by negative 2 on everything. And I would say if there's a step that you've forgotten up to this point, because we divided by a negative 2, that means we need to flip the sign, and I get positive 1x minus 3. From here, we can do our slope and y-intercept. Our slope is 1, or 1 over 1. And our b value is negative 3, which is the ordered pair 0, negative 3. And now I can graph the line, which is negative 3 with a slope of positive 1. I'm going to try to be real careful to get that line right. Anyone who's seen my videos before knows that that is not my strength. Now, whoops, I kind of messed up on the end a little bit there. Now, for this line, we need to graph greater than this line, which means that we need to graph above, which is everything over here. The problem, though, is that we only want to shade in the areas that are true for both equations. So for the first equation, I shaded everything that was greater than this line, which is over here. But I also need to be greater than this line, which means our actual shading is only what's greater than both lines. So it has to be true for both, which means this little area down here is actually not part of the solution. So we unshade that, but everything else ends up being true. So kind of in this top left region of our graph. So when we're doing a system of inequalities, we want to graph the inequalities just like we've always done before, but at the end, we need to make sure the shading is true for both inequalities. So this problem is asking, are these points solutions to the system of inequalities? And so I graphed the last system of equalities down here on the left, and it's asking, are these points solutions? Which means one of two things. Either I could plug each of these points back into both equations and see if they're true for both, or I could look at my graph over here and ask myself, are any of these points in the shaded portion? So the point 3, 6 would be over here. 0.36 is not in the shaded region. So this would be a no. It is not a solution to the system of inequalities. The point -4, -5 is right there, which is just barely in the solution set. So this would be a yes. The point 2, -1 is actually right there. That is not in the solution set. And finally, the point -3, +1 is right up here, which this would be a yes. So when we're looking for solutions to system of equations, we want to see where do the lines intersect. Solutions to the system of inequalities is, are you in the shaded region of both inequalities? Let's do one more equation. So I have 3x minus 4y is greater than or equal to 12. We need to get this into y equals mx plus b form, which I'm going to go through a little quickly here because we've done this a few times before. From here, I want to divide everything by -4, which means I need to flip the sign. And so I get y is less than or equal to +3/4 x minus 3, which makes my m +3/4 and my b -3. The b value is here. And then my slope would be up 3 and over 4. I can do that again by going up 3 and over 4 again. And now I need to graph my line. Put my arrows on the end. And I ask myself if this is a solid or dashed line. It is a solid line. And I want to shade underneath or below this equation. So that would be down here. Now I'm not going to shade too heavily because we know the shading is going to come for the other line as well. From here, I also need to get this in y equals mx plus b form. So I subtract 2x from both sides. I get y is greater than or equal to -2x plus 4. So that means my m is -2 or -2/1. My b is +4. And I can graph by doing my b as +4, my m as -2/1. I can do this as many times as I need to before I graph my line, which will be right here. I put my arrows on the end. Now this time we have a dashed line. Whoops. And I want to shade above this line. So I pick a point and I go above it, which means only this region right here will be below the blue line and above the green line. So to erase the points that are no longer true of both, I get right here.